Section 11.1, circles and ellipses. Circles have applications in seismology, aircraft traffic control, satellites, ellipses in architecture, astronomy, space science, medicine. So there's lots of applications to these problems that we're going to be doing. We're just going to start off with the basics for right now. Before we start, we want to go back to completing the square, which is what we did earlier in the year and in Algebra 2. So just as a reminder, when you are completing the square, that's so that you can usually write it in a different form for your equation, like we did parabolas in vertex form, so we completed the square to write it in vertex form. So for this first one, because I can't write this in factored form as it is, we want to complete the squared. So this would be y equals x squared plus 2x plus something to complete the square, and then if you subtract that same term, it cancels itself out, so it's like it doesn't change the equation, plus 4. So remember what completes the square, half your linear term. Well, my linear term right here is 2x, so half of 2 would be 1, and 1 squared is 1. So you have to add and subtract it so it doesn't change your equation. So that enables you to be able to go ahead and factor that part of your equation. So we get x plus 1 times x plus 1 minus, and then 1 plus 4. This right here allows us to complete our squared, which is just x plus 1 quantity squared, and then plus 3. So this would be my new equation. And this is, if you recall, our vertex form, because if you look at the vertex here, it would be -1, 3 for a parabola. So let's go ahead and do C. Also remember when you're completing the square that you can't have a number in front. If you have a number in front, you either want to divide it to the other side, or for these problems, most of the time it's going to be helpful just to factor that number out. So we get y equals 2 parentheses x squared plus, this would be 8x, plus something to complete the square minus that same number to cancel it out. And then I'm not going to factor out the 2 from the 4, so I'm just going to leave it as -4 here. When I do that, I have half my linear term, so half of 8 is 4, and 4 squared is 16, so I'm going to add and subtract 16. Now I can go ahead and factor this part of my equation when I do that. So I get y equals 2, and this would become x plus half my linear term squared, because x plus 4 and times x plus 4 gives you this right here, minus 16, and then minus 4. Now the trick is here that the 2 goes in front of this term, but we don't want the 16 inside that parentheses, so you're going to have to distribute the 2 times the 16 out. So you get y equals 2 times x plus 4 quantity squared minus 32 minus 4, and then of course we can combine like terms. And this is what we get. So if you recall, again, we did this so that we could complete the square and write a parabola in vertex form. So now we're going to be doing this for not only parabolas, but circles, ellipses, and hyperbolas as well. So we'll skip those other 2 for right now. So our objective is to construct equations for circles and graph circles on a coordinate plane. And then we'll also be doing the same for ellipses. When a plane intersects a double cone, there are 4 conic sections that occur. They are circles, ellipses, hyperbolas, and parabolas. So make sure you write that down on your paper in the space provided. The definition of a circle is the set of all points in a plane that are equidistant from a given point, and the radius is any segment with endpoints at the center and the circle. So that just means if we have something like this, this is the center, any endpoint would be on the circle, so that gives you your radius. The general equation, which you should remember from Algebra 2, is normally x minus h quantity squared plus y minus k squared equals r squared, where h and k is your center and r is your radius. And remember, we also use the equation x squared plus y squared equals r squared. So this would be if the center was at 0, 0. When you're graphing circles, if necessary, complete the square so that it is in this form that we have right here. Locate and label the center. Use the radius to measure more points by going up, down, left, right from the center, and then draw the circle. So let's just go ahead and practice with this one that we have right here. So the first thing that I would want to do is find the center of this circle. So the center of this circle, notice that we don't have anything attached to x or y, so it's going to just be 0, 0. So that's the first thing I put on my graph, which is right here. And the radius, so this is your r squared. So then r squared is equal to 16. So r would be equal to the square root of 16, which is 4. So we have a radius of 4 for this circle. So then all you have to do is count up 4, down 4, right 4, and left 4. And then just complete the circle. So of course, if your circle doesn't look quite as nice as this one right here, that's okay. I have a hard time drawing circles as well. It's not always easy. All right, so then let's go ahead and do some more practice. We want to rewrite in standard form, then find the center of radius, and then graph. So if you look at both of these, notice you have an x squared and a y squared. That's usually what helps me decide that I know this is not going to be a parabola, it's going to be a circle, because both those terms are squared. Well, the first thing you're going to want to do is get all of your x terms together, and then you're going to want to get your y terms so that they're together, and anything that doesn't have an x or a y you're going to put on the other side. So we have x squared minus 4x, and then we're going to have to complete the square so we can put it in our standard form. So plus something to complete the square, minus it to cancel it out. Now I'm going to do the y, so plus y squared minus 16y. And then we have plus something to complete the square, minus that same number to cancel it out, equals, and then on the other side we just have negative 64 because we subtracted it over there. So then the next step would be to complete the square. So to complete the square for the first one, half of negative 4 would be negative 2, and negative 2 squared is just 4, so you're going to add and subtract 4. For the next one, half of negative 16 would be 8 negative, and 8 squared would be 64. So now I am able to go ahead and write this part here in factored form. It's always the first three, and you always want to do plus the number and minus the number when you're factoring these problems, so be careful to watch out for that. So this one right here, x squared minus 4x minus plus 4 factors into x minus 2 times x minus 2, which is just x minus 2 quantity squared. And then for the next part we have plus, and then this part factors into y minus 8 because it's always half your linear term squared. And then the next step is that we want to take all the numbers that are left over, like the negative 4 and the negative 64, and we want to put them on the other side. So that means I'm going to add 64 and add 4 to this negative 64 over here. So when I do that, I end up with x minus 2 quantity squared plus, and this would be y minus 8 quantity squared is equal to 64 negative plus 64 is 0, and then you have plus 4, so is equal to 4. So then I can find the center of this. Remember, it's always opposite. So this is your h and this is your k. So the center for this circle, which I'll just write, I guess, over here. So the center is going to be 2, 8, and the radius is equal to the square root of 4, which is 2. So that's the first thing I want to find in my circle. I'm going to go over 2 and up 8, which is right here. And then I'm going to count up 2, down 2, right 2, and left 2, and then draw my circle. So let's go ahead and try the next one. So let's do the same thing. So for the next problem, first things first, you want to get the like terms together. So we have x squared minus 2x plus something to complete the square, minus it to cancel it out. And then for the y's, we have plus y squared minus 2y plus something minus the same number that completes the square equals, take the 26 to the other side. And to find the numbers that complete the square, half your linear term, so half of negative 2 is negative 1. Negative 1 squared is 1. And that is for both of them, so that's pretty easy. So now we can go ahead and factor this part here and this part here. So this ends up being x minus 1 squared, because it's always half your linear term, so half of negative 2 is negative 1. Then we have that minus 1 plus y minus 1 squared. And then, of course, don't forget you want to add the constants to the other side. So this is gone, and this is gone, and this gives us 28. So now we have x minus 1 squared plus y minus 1 squared equals 28. And then we can tell that the center of the circle is at 1, 1, and the radius is the square root of 28, which is really equal to 2 root 7, which is really equal to 5.3. So then when I put down the center, I'm going to do 1, 1, which is right here. I'm going to count up 1, 2, 3, 4, 5, and a little bit more. Right, 1, 2, 3, 4, 5.3, down, and left. And then I'm going to connect the outer points to make my circle. All right, so the next one, we're going to write the equation for a circle with the center at negative 3, 2, and radius of 3. So just remember x minus h quantity squared plus y minus k quantity squared equals 3. So in this case, this is your h and this is your k. So we have x minus negative 3 squared plus y minus 2 squared equals, and it should be 3 squared because it's your radius squared, so this should be r squared. So 3 squared. So then this gives us x plus 3 quantity squared plus y minus 2 quantity squared equals 9. And that would be my equation of the circle. Now for the next one, it's a little bit different because it says that we have the center and it goes through the point 5 and 4. So that means we have to find the radius by using our equation. So I'm using the same equation. So we have x minus 2 squared plus y plus 1 squared equals, we don't know what the radius is, so I'm just going to write r squared there for right now. But we do know we have the point x and y, so I'm going to substitute that into my equation. So I have 5 minus 2 squared plus 4 plus 1 squared equals r squared, because this is going to allow us to solve. 5 minus 2 is 3, and 3 squared is 9, plus 4 plus 1 is 5, 5 squared is 25, equals r squared. So r squared is equal to 34, and then take the square root of that would give you your radius, but we don't even need that. We just need what r squared is, because that's what goes in the formula. So I'm going to go ahead and put that up here, and we get our solution, which is our equation. So that ends circles, and now we're going to go to ellipses.